Hello and welcome back to the tied-up video demonstrations of basic physics concepts. In this video we discuss about the concept acceleration vector. Let us quickly review the concept instantaneous speed and velocity we discussed earlier. Consider the example of drive from Auburn to Atlanta. The speedometer reading of your car at different instants indicates the instantaneous speed of your motion. Assuming that the expressway is a straight road and you are driving towards Atlanta, which can be specified in the I direction in the Cartesian coordinate system, then the instantaneous velocities can be expressed as 50 miles per hour, 80 miles per hour, 60 miles per hour, and so on. Now we talk about instantaneous velocity. Consider the motion of an object from the position A to the position B during a short interval of time delta t along a specified path r. The average velocity of an object in this short interval of time is displacement AB divided by the time interval delta t. If the interval of time is smaller and smaller, the displacement becomes shorter and shorter. In the limit delta time tends to 0, the ratio of infinitesimally small displacement to the infinitesimally small time will become the rate of change of displacement or the rate of change of position vector at the point A for a given instant. This is called instantaneous velocity vector at that point. Now let us consider motion of car from velocity 22 meters per second to 36 meters per second for a given time period of 10 seconds in the positive I direction. In order for the car to move from velocity 20 I meters per second to 36 I meters per second, we have to push the accelerator, which will burn more fuel and produce more power by the engine. This in turn produces a force that is necessary to create the desired acceleration in the given direction. The change in velocity of an object in unit time is called acceleration. Acceleration of an object is a vector quantity, and it is in the direction of net applied force. In this example, we can calculate an average value of acceleration as 1.4 meter per second, or we call it as 1.4 meter per second square. This simply means that the velocity of car increasing 1.4 meter per second every 1 second on an average. A freely falling body experiences acceleration due to the gravitational pull of Earth. This is called acceleration due to gravity. For a freely falling body, the falling velocity increases 9.8 meters per second every second, or we say that the acceleration due to gravity is 9.8 meters per second square. Thus, the velocity of a ball dropped from a height will be minus 9.8 j meter per second at time equal to 1 second, and 19.6 j meter per second at time equal to 2 seconds, and so on. Now we talk about instantaneous acceleration. Consider the motion of an object during a small time interval delta t from A to B along a specified path r, where r is a function of x and y, and x and y are functions of time. Let the position vectors of the object be RA and RB when it is at location A and B respectively. Let the instantaneous velocity be VA and VB. The change in velocity VB minus VA in this time interval delta t. The average acceleration in this period is the change in velocity divided by the time taken. In the limit of delta time tends to 0, the ratio of infinitesimally small change in velocity to the infinitesimally small time will become rate of change of velocity at that point for a given instant of time. This is called the instantaneous acceleration vector at that point. Now consider a bike rider. The bike rider who starts from his garage and acquires a velocity of 5 I meters per second in 30 seconds. Calculate the average acceleration. You can see that the average acceleration is the change in velocity divided by the time taken. In this case, it is equal to 1 by 6 meters per second square. If the bike rider is moving at a velocity 5 I meters per second, comes to a complete stop in 30 seconds, what is the average acceleration? In this case, we can see that the bike rider has a negative acceleration, or we call it as a deceleration, which is equal to minus 1/6 meter per second squared. Now assume that the bike rider is moving with a constant speed of 5 meter per second along a circular track. Do you think he is accelerating at any instant during his ride? We'll discuss this answer in class, and thank you for listening, and keep watching the Tied Up videos.